Hello everybody. Today I can find the probability of a normal distribution by adding together the percents from the normal distribution curve. There's also kind of a second aim to today's lesson that we're going to talk about. I can find the confidence interval using the mean plus and minus 2 times the standard deviation. So the little formula, confidence interval equals the mean plus and minus 2 times the standard deviation. So this lesson is kind of the bridge between probability and statistics, which are very much related. So we're going to talk about confidence interval a lot more in statistics, but we're going to introduce it in today's lesson as it relates to this. So let's jump right into a problem. This that you see below is the normal distribution curve. If data is normally distributed, it will follow this curve and follow those percents. So what you see on the bottom, these are the standard deviations away from the mean. The mean is always at 0, and this is a half a standard deviation above, 1 standard deviation above, 2 standard deviations above, 3 standard deviations above. And then the flip side, this one's 1 standard deviation below, 2 standard deviations below. Of course, the halves are in there as well. 3 standard deviations below. So the standard deviations are on the bottom. The mean always goes at the 0 on the bottom. And then the percentages, you'll kind of see how that works. So let's just start. On a standardized test, the results are normally distributed. The mean is 78. So the mean goes at 0. And the standard deviation is 4. So if the standard deviation is 4, that means to get to 1 standard deviation above, I'm going to do 78 plus 4, which is 82. To get to another standard deviation, I'm going to add 4 more, 86. To get another standard deviation, I'm going to add 4 more and get 90. If I want 1 standard deviation below, I'm going to subtract 4 from 78. I'm going to subtract 4. I'm going to subtract 4. Now, if I want to fill in the halves, then I can just kind of cut the standard deviation in half. If the standard deviation is 4, and the symbol for standard deviation is a sigma, that's your symbol for standard deviation, so we're going to be using that just to make our life a little bit easier. It's a lot easier to write sigma than to write out standard deviation. So half of a standard deviation would be 2. So this would be 80, 84, 88, 76, 72, 68. Now, I just want to give you a heads up. This lesson, you do not need this lesson in order to get any questions correct on the Algebra 2 regions. We're going to do it on the Algebra 2 regions in the calculator in the next lesson, but this lesson is to show you where this stuff is coming from. Because if not, you're just blindly substituting things into the calculator. I want you to have somewhat of an understanding of what you're putting into the calculator. This confidence interval thing, though, is definitely going to come up on the Algebra 2 regions. But this curve, you're not going to see. You're going to do it in the calculator, but I want you to understand where the numbers are coming from. That's why we're going to use the curve today. What is the confidence interval? So, confidence interval. Let's write CI for short. Is the mean plus or minus 2 times the standard deviation. So we talked, I don't know if we have talked about it yet. The mean is x bar. So we're going to use that as a symbol for the mean. It's just going to make our life easier. So the confidence interval is the mean, 78 plus 2 times the standard deviation, and 78 minus 2 times the standard deviation. You can use a calculator if you need to. I will, just so you can see where the numbers are coming from. 78 plus 2 times 4, and then 78 minus 2 times 4. 86 and 70. So the confidence interval is between 70 and 86. We always write the smaller number first and then the larger number last. So let's talk about what this means. This means that the expected values, the confidence interval is the expected values for this standardized test. So it's expected, it's normal for a grade to be between 70 and 86. Does it mean that it has to be between 70 and 86? Doesn't have to, but it's expected. If it's not between 70 and 86, then there's a reason that it's not between 70 and 86. It's unusual if it's not between 70 and 86. It's the range of, another word you'll see is plausible. It's the range of plausible scores. If the score is in the confidence interval, then it's expected, it's plausible. If it's not, then it's not. So is a score 71 plausible? Yes. 71 is plausible because it's in the confidence interval. I'm kind of running out of space here. Is a score of 98 plausible? Well, is 98 between 70 and 86? No. So I would say that 98 is not plausible because it's not in the confidence interval. So either yes, it's plausible because it's in between these two values that make up the confidence interval, or it's not because it's not inside. And if you're looking at the curve, the confidence interval is always between -2 and 2. Another thing about the confidence interval is that it always contains 95% of the data. From here to here, if I had to add all these up, you're going to get 95%. The confidence interval is 95%. So this score 98, it's not impossible. There could be a kid who has been studying his whole life for this exam and got a really, really, really high score, but it's not an expected value. I would not expect that a student's going to get a 98. It's possible, but I wouldn't bet any money on it. All right, there's one more question. What is the probability that a randomly selected score is between 76 and 82? So let me just get a different color. So here's what you need to do to answer that. 76, 82. We are going to add all the percentages that are between 76 and 82. So I have this bar, and this bar. So it's going to be 19.1 plus 19.1 plus 15. 19.1 plus 19.1 plus 15 is 53.2. And that's your answer, 53.2%. So there's a lot of different things we did in this problem. Let's go over it one more time. First, it told me that the mean was 78 and the standard deviation was 4. So I put the mean at 0, and if the standard deviation is 4, each one I'm going to add 4. So 78 plus 4 is 82, plus 4 is 86, plus 4 is 90. I can add in the halves by taking half of 4. Half of the standard deviation was 2. That's where 80 and 84 were coming from. We do the same thing down the other way. If the standard deviation is 4, I'm subtracting 4 for the full standard deviations. I'm subtracting 2 for the half standard deviations. The confidence interval is just a formula. It's the mean plus and minus 2 times the standard deviation. So I did that, and I got this. The confidence interval is the middle 95% of the data. It's the range of expected values. So to determine if a score is plausible, we need to determine if it's inside the confidence interval or not. 71 is between 70 and 86, so it's plausible because it's in the confidence interval. 98 is not plausible because it's not in the confidence interval. It's not between 70 and 86. The final question that it asked, what is the probability that a randomly selected score is between 76 and 82? So 76 is here, 82 is here. We're adding up all the percentages between them. In tomorrow's lesson, we're going to do this last question, in the calculator. There's a way to do it in the calculator without the curve, because obviously if I don't have the curve, I can't do this. So for this lesson today, you're going to have the curve, and then tomorrow when I take the curve away, we're going to do it in the calculator. On the Regents, you will do it without the calculator, because you will not be given the curve. All right, they're all the same. So we're going to go through one more together, then I'll have you try one on your own, and then that will be it. On a test that has a normal distribution of scores, 82 is the mean, and the standard deviation is 2. So the mean is 82, the standard deviation is 2. So I put the mean at 0, and then if the standard deviation is 2, I'm going to add 2 to get to 1, add 2 more to get to the next full 1, add 2 more, subtract 2 in the other direction, subtract 2, subtract 2, and if I want to fill in the spaces in between, half of the standard deviation, half of 2, is 1. So that would be 83, 85, 87, 81, 79, 77. What is the confidence interval? Well, the confidence interval is the mean plus and minus 2 times the standard deviation. The mean is 82. The standard deviation is 2. I want you to pause it, calculate the confidence interval on your own, and then unpause it. Okay, now that you calculated it on your own, let's see if you got it right. The mean is 82 plus 2 times the standard deviation, which is 2, and then 82 minus 2 times the standard deviation. You can use the calculator if you need to. I don't need to. 82 plus 4 is 86. 82 minus 4 is 78. So the confidence interval is 78 to 86. And what that means is that the range of expected values is between 70 and 86. I would expect that you're going to get, it would be expected for you to get a 78, a 79, an 80, an 81, an 82, an 83, an 84, or an 86, 85, or an 86. It would not be expected for you to get 77 or lower. It would not be expected for you to get 87 or higher. It's possible. I'm not saying you can't get a score that's higher or a score that's lower, but I would not expect that. It would be unusual for you to get a score that's not between 78 and 86. Is a score of 97 plausible? Is a score of 81 plausible? Well, you have to look to see, are those values in the confidence interval? To determine if something's plausible or expected, I need to see if it's inside the confidence interval. 97 is not inside. It is not between 78 and 86. So 97 is not plausible because it's not in the confidence interval. Is a score of 81 plausible? Well, 81 is in between 78 and 86. So 81 is plausible because it's in the confidence interval. Final question. What is the probability that a randomly selected score will be between 78 and 84? 78, 84. Add all these bars in between them. So it's going to be 4.4 plus 9.2 plus 15.0 plus 19.1 plus 19.1 plus 15.0. 4.4 plus 9.2 plus 15.0 plus 19.1 plus 19.1 plus 15.0. That's it. Whoops, that would have been bad. And I get 81.8%. So let's talk our way through it one more time. The first it gave me the mean and the standard deviation. The mean goes at 0 on the bottom. The standard deviation is how much each full one is worth. So I'm adding 2 to get the full standard deviations and subtracting them. And if I want to fill in the spaces in between, I take half of the standard deviation, which is 1, and I would kind of fill in the 1 from there. It asks for the confidence interval. This is your formula for confidence interval. It's going to come up a lot in this course. It's the mean plus and minus 2 times the standard deviation. So I did that calculation to come up with this. That's the range. That's the middle 95% of the data. It's the range of expected values. It's the range of plausible values. So a score is plausible if it falls inside the confidence interval. 97 is not between 78 and 86, so 97 is not plausible because it's not in the confidence interval. 81 is between these values, so 81 is plausible because it's inside the confidence interval. The final question, it asks for the probability that a randomly selected score will be between 78 and 84. So I found 78 on my curve, I found 84 on my curve, and I added up all the numbers in between. I popped them into the calculator. I got my 81.8%. There's no twist to this. There's a lot of little pieces to this lesson. So I think it's time for you to practice this one on your own. I'm going to let you try this one completely on your own. So I would like you to pause. Try number 3 completely on your own. It might take you 3 or 4 minutes. And then unpause. I'll go over it. And then your classwork / homework will be to finish. So again, please pause. Try number 3 on your own. And then unpause. Okay, now that you tried number 3 on your own, I will go over it. If the amount of time students work in any given week is normally distributed with a mean of 10 hours per week and a standard deviation of 2 hours. So the mean is 10, that goes at 0. The standard deviation is 2. Mean is 10. Standard deviation is 2. So I'm adding 2 to get to the whole standard deviation above, adding 2 more to get to the 2, adding 2 more to get to the 3. I'm subtracting the 2 to get the negatives. And if I want to fill in the spaces in between, half of the standard deviation, half of 2 is 1. So the half boxes are going by 1, the full boxes are going by 2. What is the confidence interval? Well, the confidence interval is the mean plus and minus 2 times the standard deviation. The confidence interval is 10 plus 2 times 2 and 10 minus 2 times 2. That's 14, that's 6. So the confidence interval is between 6 and 14. Now that I have that, is a time of 13.5 hours plausible? Well, this is the range of expected values. I don't care how close it is to the edges. If it's inside, it's plausible, it's expected. If it's outside, it's not. So is 13.5 between 6 and 14? Yes. 13.5 is plausible because it's in the confidence interval. 18.1 is not in between those, so 18.1 is not plausible because it's not in the confidence interval. So I am not going to expect to see a value of 18.1. Is it possible? It's possible, but it's not an expected value. I'm not going to plan for that. The final question, what is the probability that a randomly selected student will work between 8 and 12 hours? 8, 12, add all the percents in between, 15 plus 19.1 plus 19.1 plus 15. 15 plus 19.1 plus 19.1 plus 15 is 68.2%. So it's expected that 68.2% of the students in this town or high school or whatever work between 8 and 12 hours. So I would need to plan accordingly. If I was giving homework or whatever, I would need to plan accordingly and understand that 68.2% of my students are going to be working between those hours. So a lot of little pieces to it. I can find the probability of a normal distribution by adding together the percents from the normal distribution curve. And again, to get the values on the bottom, the mean always goes at the 0. And then you're adding and subtracting the full standard deviation at the full value. You can cut it in half to find the spaces in between. Confidence interval is the mean plus and minus 2 times the standard deviation. That gives you the range of expected values. And again, that's a concept you're going to see a lot throughout the rest of this course. The classwork/homework is going to be to finish this assignment. And in the next lesson, we're going to learn how to do this without the curve. Have a great day.